Hello. Since I've just started teaching about Newton's laws of motion in my first year mechanics class here at Maynooth, I thought I'd just record a little short video going into the terminology and a little bit of the history of these laws, which form the foundations of uh, mathematical physics and are still in widespread use today. So I thought I'd start by just showing you the kind of cover page, if you like, of the Principia, and just mention the date, which is 1686. Here, that's the imprint date. You'll notice the date in Roman numerals down here. The actual publication date is actually just a year later in 1687. This portrait of Newton on the left here is quite a famous one, and it's roughly contemporary with the publication of this. It's actually a few years earlier, but it shows Newton roughly as he would have looked at the time when he published the Principia. He was about in his 40s at that time. Now, the interesting thing about this, when we look at the laws of motion specifically, you'll notice two things, or several things probably. One of them is that it's all in Latin. It's also in a rather, to modernize, difficult typeface, so it's quite difficult to read. I actually did quite a lot of Latin at school, and it is quite difficult to read if you've studied classical Latin, because of course it's 17th century English Latin, if you like. But Latin was largely the medium for scholarly communication at that time, although there was a time of transition, because Newton's second great book was the Optics, published about 15 years later, and the Optics is actually written in English, not in Latin. So because it's not so easy to read on this kind of page, I've pulled out the three laws of motion as they are in the original Principia, and you'll see them there. And it won't necessarily mean much to you if you haven't studied Latin. But here are the same three laws in a modern kind of school textbook version. Every body continues in a state of rest or uniform motion in a straight line unless acted on by an external force. That's reasonably familiar. The rate of change of momentum of a body is proportional to the impressed force and is in the direction in which this force acts. That's the second law. And the third law is for every action there is an equal and opposite reaction, body A, body B, and all that. Now, the interesting thing about this is if you go back to the Latin version, the word momentum appears in the modern statement of Newton's laws in the second law, and momentum is a word of Latin origin, but it's not the word that Newton used in his statement of the second law. The word he uses here is motion, a change of motion. So somewhat surprisingly to me as a non-historian, the word momentum is not the word that's used, and it's not an original concept of Newton. So I was kind of interested in this, and because I work in this place, not actually in this building, but this is the historic St. Patrick's College on the south campus of Maynooth University. This was began to be built in the late 18th century, in the 1790s. And I thought it would be interesting to dig out an English translation of the Latin Principia from about that time. So the nearest I could get was 1792, which is not far off. And we see the Newton's laws here stated again in late 18th century language. So the first one is, every body perseveres in a state of being at rest or of moving uniformly straight forward, except insofar as it is compelled to change its state by forces impressed. That's very similar to the modern statement. Newton's second law here, now this is an edited version, I'll go to the long version later. The alteration of motion is ever proportional to the motive force impressed and is made in the direction of the right line in which that force is impressed. So that's pretty familiar as well. And the third law, body A and body B, is actually to every action there is always opposed and equal reaction, or the mutual reaction of two bodies upon each other are always equal and directed to contrary parts, which is probably not the way you would say that in modern English, but it nevertheless is comprehensible. So I thought this is show you the full version of Newton's second law, not the edited highlights that were on the previous slide. And you'll see that the bit that I showed you was just the first sentence of this, and it goes on. So let me just pick up on a couple of things. So the phrase, the alteration of motion, remember this is 1792, still doesn't use the word momentum. So I got interested, when did people start using the word momentum in Newton's second law? So I went to the Fount of All Wisdom, which is the Oxford English Dictionary online, and found there's various definitions of the word momentum, not all of them to do with physics. But you'll see here that it defines, in physics and mathematics, momentum is the quantity of motion. A phrase we wouldn't use nowadays, but it was, if you look at the quotes below, it's kind of what people were, an expression that people were using for what we now call momentum. The quantity of motion in a moving body now expressed as the product of mass and velocity. That's how we teach it nowadays. Now you'll see the first usage of this momentum is 1699, given here. Now that's the oldest that can be found by the people at the OED. That dates after the original publication of the Principia. And it refers to it, of course. According to the laws of motion, the momentum or quantity of motion of both bodies taken together would remain the same. That's talking actually about a collision in which momentum is conserved. And it clearly refers to the laws of motion being Newton's laws here, I think. The next one given here is 1791, almost the same date as the English translation. And you'll see here the momentum of bodies depends on the quantum of their velocity multiplied into that of their matter. It doesn't mean quantum mechanics here. It just means the quantity of the numerical value of their velocity multiplied into that of their matter, which in modern language would be mass in kilograms or something. Okay, so the word momentum actually was introduced into physics quite a long time after, well, it was introduced after the publication of the Principia, as far as we know, but it actually gradually came into usage to describe Newton's second law. It's rather interesting how that came about. Now let's go back to the statement, the long-winded statement of Newton's second law, and you'll see here in red the second part. If a force generates a motion, a double force will generate double the motion, a triple force triple the motion, whether that force be impressed altogether and at once or gradually and successively. Well, that's just expressing the proportionality, right? So if you double the force, you double the motion, etc. And it doesn't matter whether you do that at the same time. So you could give a particle a shove, impose a force on it, and then give it another shove, and those shoves act cumulatively. So that's fair enough. But the second sentence is really rather impenetrable. And this motion being always directed the same way with the generating force, if the body moved before is added to or subtracted from the former motion, according as they directly conspire with or are directly contrary to each other, or obliquely joined when they are oblique, so as to produce a new motion compounded from the determination of both. Well, that's a bit of an ordeal to read through. What Newton is saying here in translation is that the forces or the changes of motion, in order to work out the effect of a number of separate forces, you have to take into account the direction and the magnitude of those forces. And so what he's saying is that force has a magnitude and direction. And so I can use the little prop here that I've been using in lectures to indicate a vector. And the net result of a combination of forces is the vector sum of those forces. I take this as being a statement, kind of cry for help through the centuries from Newton, saying he wished he'd known about vectors when he was doing this, and he wouldn't have to use this convoluted language. So I just end with a quick picture of this showing what I mean. This is a standard textbook example from first year mechanics, where you have a massive block sliding down an inclined plane, and you see the various forces. On here, we've got the weight of the block downwards. That's the force on it produced by gravity. We've got a friction force opposing its sliding motion in the direction of the plane. And we've also got the normal reaction arising from the fact that the plane is pushing back on the block as it tries to sink into it. And that is the normal reaction comes from Newton's third law.